Greetings, salutations, all those nice things. Welcome to the last part of this first glance at trig this year. So we're going to look at some trig equations. Some of these could appear in a calculator section, some could appear in a non-calculator section. We'll have to be familiar with both. So we're going to look at these. We'll figure out if a non-calculator solution is possible or if an exact answer can be provided. If it can't, we'll round to 3 decimal places as usual. Key thing is to be able to isolate the variable. And in order to do that, we're going to have to isolate the trig function itself. And once we do that, once we solve, we'll get our 0 to 360 values, or we'll get our 0 to 2 pi values, but then pay careful attention to the domain. Is the domain going for 1 revolution? Is it going for like half of a revolution somewhere else? 2 revolutions in this case. So we'll have to be very, very careful of those things. In this first case, what we can do here is we can subtract 3 cotangent theta from both sides. And if we want, we can even subtract 3 from both sides, because then in that case we'll have 1 cotangent theta, and 4 minus 3 is 1. I don't know this secondary trig ratio business. I will turn it into tan theta and say that tan theta is the reciprocal of 1, which is 1. That has a reference angle of 45 degrees, or in radians, pi over 4. If tan theta is positive, because that's positive 1, we're looking at quadrants 1 and 3. In that case, I will say that theta could be, in quadrant 1, it's just straight up pi over 4. And in quadrant 3, pi plus pi over 4 is 5 pi over 4. And that one's done. Sweet. Honestly, feel free to try the other ones if you want. Even this one that's a bit more of a doozy. You can even scroll on to the next page if you want to read up that stuff. But pause however you need to. See what happens. What am I doing here with my life? Probably solving. Alright, so I'll subtract 5 root 3 from both sides, which tells me that 4 cos theta is negative 2 root 3. I'll have to divide by 4. Which tells me that cosine of theta is negative root 3 over 2. If you want to reference a special triangle for that, whoopsie daisy, that's 2. That's root 3, that's 1. Looks like we're dealing with this angle right here, so we got ourselves a reference angle of pi over 6. And from 0 to 360, oopsie daisy, we would say that since cosine is negative, we're dealing with quadrants 2 and 3. In quadrant 2, theta would be 5 pi over 6, and quadrant 3, 7 pi over 6. But theta is from 180 to 360 degrees. Oh, whoops, we're not even radians? Who did that? So if we actually look at our angle as 30 degrees, alright. Quadrant 2, 150 degrees. And quadrant 3, 210 degrees, but again, still looking at this domain, we have to be from 180 to 360, which means that we can't really take that one. So our only possible answer is 210 degrees. This one, yeah, there's a quadratic in there. Help, help, I'm scared. We're not scared. We are bold, adventurous beings. I'm going to let x be sine theta. Now, you don't have to do this. If you can factor this just from seeing it, do it. But if you need to see it as being something more like this, then go for it. Do that. This is called parametrizing, where we introduce a new variable to represent some form of another one. So if you need to do that, go for it. And I'm going to show it that way. But these few steps aren't necessary if you can jump straight to the factored form. So you're going to have to factor this. There's going to be 3x and x and I don't know what. Minus 2 plus 1. Wicked cool. Which means that x is negative 1/3 or x is 2. If you had done this the other way, you would have just jumped straight to saying 3 sine theta plus 1 times, sine theta minus 2 equals 0. Therefore, sine theta is negative 1/3, or sine theta is 2. So, from this step, we would take ourselves over there. Looking at this, first of all, I can tell that we're going to have to use a calculator, because this is not a special ratio at all. So, okay, we can do that. That's no problem. Reference angle will be the inverse sine of positive 1/3. And this one, my goodness. Sine theta has to be between negative 1 and 1. So 2 is a big ol' nope. That one has no solution. Continuing with the one that does, our reference angle is the inverse sine of 1/3. In degrees, that's like 19.471 something degrees, but we're not in degrees. We're actually dealing with radians. Psych. So when you calculate that, do make sure that your calculator is in radian mode, and then you can get it. So inverse sine of 1/3 in radians is 0.340. Checking out cast rule. Sine theta was negative, so we're actually dealing with these two quadrants. In quadrant 3, we're talking about pi plus this. Plus, where's my pi button? That's 3.481. In quadrant 4, we're talking about 2 pi minus this. Where are we at? So 2 pi minus my answer, which is 5.943. But we can also go as high as 4 pi, so we need to add whatever is coterminal. So if we add 2 pi to each of those, this one's already on my screen, so plus another 2 pi is 12.227. And this other one, let's go back to inverse sine of negative 1/3, or positive 1/3. What did we do? We added pi to get to 3.481, and let's add another 2 pi. gives me 9.765. So all of our possible values of theta are 3.481, 5.943, 9.765, and 12.227. That's that one done. Woo! It's a doozy. So these ones all had restricted domains. This one went 0 to 2 pi, 188, 360, 0 to 4 pi, super duper. We might also be tasked with finding a general solution. So that's one where we don't have a restricted domain. So determine the general solution for theta, according to this one. And we're specifically asked in this case to provide it in degrees. What we're going to do then is we're going to find the base angle, the one from 0 to 360, and then we're going to provide all coterminal angles. So remember that general form of a coterminal angle, which we saw way back in the day somewhere. This stuff right here on page whatever that is. This is in topic 1, or part 1 of topic 3. So from way back, that stuff, that's what we're going to be relying on here. So in we go. Let's scroll back to wherever we were. Shazam. Ow. So here we can say that cosecant of theta, or cosecant of theta is -5. Cosecant of theta is -5/4, which means that sine of theta is -4/5. So definitely have to use calculator for this one. My reference angle is inverse sine of +4/5. Well, I better switch my calculator back to how you say degrees. Otherwise that would be devastating. So inverse sine of 4/5 gives me an angle of 53.130 degrees. The sine of theta was negative. So quadrants 3 and 4. In quadrant 3, 53.130 degrees is related to 233.130 degrees. And in quadrant 4, 360 minus that is 306.870 degrees. So those are our answers from 0 to 360. But we want the general solution. Well, in that case, we can take 233.130 and add 360 degrees as many integer times as we want. Or we can take 306.870 degrees and add 360 degrees as many times as we want to that. So these are our possible answers. If we're introducing k, we do have to specify what it is. So theta could be those things as long as k is an integer. That is our answer. So our base version is there, which came from here, and then adding any multiple of 360 to get something coterminal. Quick, try the others. There is no time. Oh, there's only one. Try the other. There's no time. Race you. Oops. we got two options here, so do be careful. Sine theta could be root 3 over 2. That's true. But we could also say that sine theta is negative root 3 over 2. So do be careful whenever you're taking the square root of something, that you're not just saying it has to be the positive square root, that you do have options. So for this one, we're dealing with a reference angle, actually for either of them, because they're both the same ratio. Just difference is positive, negative. So root 3 over 2, 1, 2, root 3, opposite over hypotenuse. So we're dealing with a reference angle of pi over 3. And where could we be dealing with in terms of solutions? For this first one, we're dealing with quadrants 1, 2. For this other one, we're dealing with quadrants 3, 4. So actually, we're dealing with all of them. In quadrant 1, that's just pi over 3. In quadrant 2, 2 pi over 3. In quadrant 3, 4 pi over 3. And in quadrant 4, what happened there? 5 pi over 3. But we're not just stuck between 0 and 2 pi. We can have anything coterminal to that. So theta could be pi over 3 plus 2k pi, or it could be 2 pi over 3 plus 2k pi, or it could be 4 pi over 3 plus 2k pi, or it could be 5 pi over 3 plus 2k pi. So your first angle plus anything coterminal to it, your second angle plus anything coterminal to it, your third angle plus anything coterminal to it, and your fourth angle and anything coterminal to it, as long as k is an integer. Do not forget this specification. It is necessary. This stuff can be tricky. I do acknowledge that. But again, as I stated at the end of the last lesson, you got to practice this one often. Like, you have to practice it a lot just to make sure you really know what you're doing. And do always pay careful attention to what the question is asking. So whether it's asking you to solve, provide your answer in radians or degrees, whether that's implied by the domain that's given, all that stuff kind of comes into play. On your provincial exam, if a question does require a calculator, don't forget you'll see a little calculator icon like this. It'll be like, oh yeah, I need to use my calculator for that. Cool. But that's the cheese there. Practice all this stuff like crazy. So do it all, and once again, let me know if you have any questions, comments, concerns, anything you struggle with. Make sure you forward that my way, or seek out another resource if you have another resource. There are some questions from the January 2019 provincial, if you want to take a look at that, all to do with the stuff we did in this topic. Don't forget that the marking guide is online. The link to all those provincial assessments is on Teams, so please do make sure you actually check the marking guide, like the solution guide, when you actually do these questions, just so you have a sense as to how you would do if you encountered those questions on an exam. So that's all for this. I will see you in the future. Don't forget to eat your vegetables. Goodbye.